this video lesson on bubble sort. This is a one-off sorting algorithm you have to learn in your course COU 3306 Data Structures and Algorithms. This course is a part of BSc in Information Technology degree program offered by the Department of Computer Science, the Faculty of Natural Sciences, the Open University of Sri Lanka. Let's see the learning outcomes of this video. At the end of this video lesson, you should be able to explain the working principle of bubble sort algorithm, and you should be able to illustrate bubble sort with step-by-step passes. And also, you should be able to analyze the time complexity of bubble sort algorithm. Before going to see the logic behind this bubble sort, let me explain the bubble sort using a day-to-day example for you. It will help you for the visualization. Imagine that you are having 4 balls with different values. Here, the balls are not in any order, but now I am asking you to place them in ascending order. So, my dear students, what is mean by ascending order? Ascending order is the arrangement of the items from smallest to largest one. So, now I am going to arrange these balls in ascending order. So, here first I am comparing first 2 consecutive balls. Here you can see that 7 is greater than number 4. So, what you have to do here is you have to swap these 2 balls. Then you are going to compare the second and third balls. Here number 7 is greater than number 6. So, again you have to swap these 2 balls. Now, you are going to compare last 2 balls. Here, number 7 is greater than number 2. So, you have to swap these 2 balls again. Once you have done this process in one line, then you can understand that the largest element has bubbles up to the end. So, now you have to repeat this process until all other balls have in ascending order. So, now you have to start from the beginning again. Therefore, now you are going to compare first 2 consecutive balls again. Here number 4 is less than number 6. So, you do not need to swap these 2 balls. Then you are moving to second and third balls. Here number 6 is greater than number 2. Therefore, you have to swap these 2 balls. Right. Again, you are going to do this process from the beginning. So, you are comparing first 2 consecutive balls. Here, number 4 is greater than number 2. Therefore, you have to swap these 2 balls. So, again, now you have to start from the beginning. Here, you have only 1 ball. That is number 2. So, these 4 balls are now in ascending order. The beauty behind this process is you have used bubble sort to order these 4 balls. Shall we go through some key terms related to this activity? Here we have compare the balls with different values. In algorithms, these values are called as elements, and the set of elements is an array. We have performed comparisons in several rounds. Each round is called as a pass. Okay, let's see how this algorithm works using a list of elements. The set of elements shown in this slide is an array called A. So, this A array consists with 5 elements. Okay, my dear students, let's take 1 minute and recall your memory how bubble sort works. In each time, we are comparing 2 consecutive values. If first value is greater than the second value, then we are interchanging those two. Okay, shall we use this theory to sort this array? To see how this algorithm works very easily, I am writing this array in vertical. So, here first value is number 7, the second value is number 4. So, we are comparing those two values. Number 7 is greater than number 4. So, 4 goes up and 7 goes down. And then 6, 2 and 1 are remaining as they are. Then we comparing the second and third values. Here you can see that 7 is greater than number 6. Therefore, we write 4 as it is, and then 6 goes up and 7 goes down. And then 2 and 1 are remaining as they are. As the next round, you are comparing 7 and 2. Here you can see that 7 is greater than 2. Therefore, first two values are remaining as they are. Then number 2 goes up and number 7 goes down. Finally, 1 is staying as it is. And next, we are comparing 7 and 1. So, number 4, 6, 2 are remaining as they are. Then, since number 7 is greater than number 1, 1 goes up and 7 goes down. So, my dear students, now we have performed the comparison in one round. Here you can see that the largest value has bubbles down. So, this round is called as a pass. So, this is the first pass you have performed. Can you tell me what is the result of the first pass? The result is the largest element goes down. So, what is the largest element? That is number 7. My dear students, can you tell me how many comparisons we have performed in the first pass? 1, 2, 3 and 4. So, for the 5 elements we have performed 4 comparisons. And you have to remember that if you have n elements, then you have to perform n minus 1 comparisons. Okay, let's move to the second pass. What is the state of the result we received from the first pass? 4, 6, 2, 1 and 7. Okay. Now take your time to perform the second pass by yourself. So pause this video and take a piece of paper to follow the following steps. You have to compare the values from the beginning of the pass. You have to exchange the values if the first value is greater than the second value, and then you have to repeat this process until you have finished the second pass. When you have finished the second pass, resume this video and please check your answer is correct and align with my answer. Great. Let's work with the second pass together. Here, first we are comparing first two elements, number 4 and 6. Here, 4 is less than 6. So, we do not need to swap those two values. Therefore, the values 4, 6, 2, 1 and 7 are remaining as they are. Then we comparing the second and third values. Here, number 6 is greater than number 2. Therefore, the first value 4 is remaining as it is. Then, number 2 goes up and number 6 goes down. Rest of the elements are staying as they are. Then, we comparing number 6 with number 1. Here, number 6 is greater than 1. Therefore, first 4 and 2 is remaining as it is. Then 1 goes up and 6 goes down. And finally, the 7 is remaining as it is. Next, what I have to do is, I have to compare 6 and 7. Do we need to compare those two values? No, because they are already sorted. So, can you tell me how many comparisons we have performed? Totally, we have performed 3 comparisons. So, this is the second pass. Then, we have to move to the third pass. My dear students, what is the state of the result we got from the second pass? 4, 2, 1, 6 and 7. So, dear students, this is your next activity. Take this time to perform the third pass. So, you have to follow the same procedure we have followed previously. You have to compare the elements from the beginning of this pass and you have to swap them if the first value is greater than the second value. You have to repeat this process until you have reached to the end of the pass. When you finish the third pass, resume this video and check your answer with my one. Okay, let's verify your answer. We start with this list: 4, 2, 1, 6 and 7. Now you are comparing first two values, 4 with 2. 4 is greater than 2. So, you are swapping those two values. 2 goes up, 4 goes down. Then, remaining 1, 6 and 7 are placing as they are. Then, you are comparing second and third values. Here, 4 is greater than 1. So, you have to swap them. So, can you tell me what is the result? 4 is going to down and 1 is going to up. Therefore, 2 is remaining as it is at the first place. Then 1, 4 and 6, finally we can see 7. Now you can see that last 3 elements are sorted. So, we do not need to compare 4 with 6 or 4 with 7. So, can you tell me how many comparisons we have performed now? That is 2 comparisons in the third pass. Okay, I will perform one more pass. Here the status is 2, 1, 4, 6 and 7. So, now I am comparing first 2 elements. Here 2 is greater than 1. So, 1 goes up and 2 goes down. And finally 4, 6 and 7 are remaining as they are. Then I will compare 2 with 4 and 2 with 6 and 2 with 7. Actually it is no needed because 2, 4, 6 and 7 are sorted. And I have remained the first element, that is number 1. It is also already sorted. So now we have performed one comparison in the fourth pass. This is how bubble sort works. Let me explain the time complexity of the bubble sort now. We have performed the bubble sort using 5 elements. And now, can you tell me how many passes you have performed? Totally, you have performed 4 passes. Dear students, how many comparisons you have performed in each pass? You can see that in the first pass, you have performed 4 comparisons. In the second pass, you have performed 3 comparisons. In the third pass, you have performed 2 comparisons. In the fourth pass, you have performed 1 comparison. Okay, now think. If you are given n number of elements, how many passes you have to perform? Yes, that is n minus 1. Then, as we already see, number of comparisons in 5 elements is 1 plus 2 plus 3 plus 4. Then, how many total comparisons do you need to perform for the n elements? That is 1 plus 2 plus 3 plus, and it goes up to n minus 1. This is the sum of natural numbers up to n minus 1. Therefore, we can write it as n into n minus 1 divided by 2. That is order of n squared. So, the total number of comparisons we have to perform is order of n squared. My dear students, the time complexity of a given sorting algorithm is expressed by the number of comparisons. Therefore, here the time complexity of bubble sort is order of n squared. Let's see the summary of this video lesson. In this video lesson, we explored bubble sort, that is one of the simplest sorting algorithms. You saw that bubble sort works by repeatedly stepping through the list, comparing each pair of adjacent elements and swapping them if they are out of order. Each full pass bubbles the largest unsorted value towards the end. Using a small array of 5 numbers, here we observed that there are 4 passes and number of comparisons are given by the summation from 1 to 4. Then for n elements, bubble sort needs up to n minus 1 passes. The total comparisons in this case are n into n minus 1 divided by 2, which is order of n squared. That is the time complexity of bubble sort algorithm. Dear students, bubble sort is easy to understand, but keep in mind that this is not the most efficient algorithm for large arrays. Thank you very much for watching. Keep practicing bubble sort.